start like the mindset of geometry, the reasoning, deductive reasoning skills you're going to learn. Our first vocab word today, a conditional, is an if-then statement. Conditional statements are if-then statements. If it is sunny, then I need my sunscreen. If it is raining, then I need my umbrella. If it snowed, then I need to shovel the driveway. Those are all conditional statements. Our postulates and our theorems, we'll get to theorems later in the chapter, are also a lot of times written as a conditional. The first postulate, or not the first one, but like the second one, if two lines intersect, then their intersection is a point. If two planes intersect, then their intersection is a line. If, conditional, it's hypothetical, if it happens. If two lines intersect, then they must intersect at a point. Do two lines have to intersect? Give me a counterexample. Parallel, or, starts with an S, skew, good. Okay, so conditional statements, if then, if the hypothesis, the if part is true, then the conclusion has to be true to follow it. Hypothesis, that's the if part. So you have to write down the if part. The conclusion, that's the then part. Hypothesis follows if, the conclusion follows then. Hypothesis if, conclusion then. Hypothesis if, conclusion then. Truth value. The truth value of a statement is true or it's false. That's all you really have to write down. It can either be true or it can be false. Can't be both and it can't be neither. Statement's either true or false. This next chunk you don't have to write it down, but you totally can if you want to. To show that a conditional statement is true, you need to show that every time the hypothesis is true, the conclusion is true. So every time two lines intersect, then their intersection has to be a point. Okay? There's no way to draw two intersecting lines that won't intersect at a point. That's a true statement. If you're going to show that a statement is false, then your counterexample has to be true for the hypothesis, but false for the conclusion. Counterexamples keep the hypothesis true, and then they make the conclusion false. So if I were you, on the word where it says a counterexample is, I would write is an example that makes a conditional false. Counterexamples. Example that makes conditional false. Counterexample is an example that makes a conditional false. It has to keep the hypothesis true, but make the conclusion false. That's how you get your counterexample. It only takes one counterexample to make something false. There might exist 2, 3, 18, 87 counterexamples, but you just need to give me one if you're going to give something false. Converse of a conditional statement, if P then Q, is the statement if Q then P. So you are writing is the conditional if Q then P. What happened with the P's and the Q's? Bless you. They switched around. What did the P represent in the first one? Followed the word if. Good, the hypothesis. Q represents the conclusion. And then you guys said the P and the Q switched around. A converse switches the hypothesis and conclusion. Maybe you want to write that as a side note. Converse switches hypothesis and conclusion around. So that first one I used, if it is sunny, then I need my sunscreen. The converse, if I need my sunscreen, then it is sunny. If it is raining, then I need my umbrella. Converse, if I need my umbrella, then it is raining. You're just switching the hypothesis and conclusion around. You're swapping them for each other. There's another example there right below, counterexample. If an angle is a straight angle, then its measure is 180. Converse, if the measure of an angle is 180, then it is a straight angle. Swapping the hypothesis and conclusion around. Brooke, the conditional statement, if an angle is a straight angle, then its measure is 180. True or false? True. Anna, how about its converse? If the measure of an angle is 180, then it is a straight angle. Why? Okay. What do we call an angle of 180 degrees? So if the measure is 180 degrees, then is it a straight angle? So your converse, true or false? True. Yeah, they're both true. Just because they switch doesn't mean they negate each other. Sometimes they will. Sometimes your converse might come out false. Sometimes your conditional starts false and then the converse is true. It just depends. When they're both true, it's called a biconditional because it works both ways. All right. Homework, bless you, all week is worksheets. So if you were bringing your textbook, you don't need to use your textbook this week. Just to let you know, you're getting a worksheet today. Your first example says identify the hypothesis and conclusion. On your worksheet today, it's going to say underline your hypothesis once and your conclusion twice. So if you want to do that on the notes, that's what I'm going to do. That way you don't have to write them all out. So our conditional statement, if two lines are parallel, then the lines are coplanar. I want to identify the hypothesis and conclusion in that statement. Julia, the hypothesis comes after which word? And the conclusion, Julia, comes after? Good. So our hypothesis would be two lines are parallel. Conclusion, the lines are coplanar. Yes, ma'am. Oh. Don't remember first part, second part. Because sometimes it'll be like, it is sunny out if I need my sunscreen. That sentence didn't make sense at all. I need my sunscreen if it is sunny out. I threw the if in the middle. So your hypothesis has to follow if. It doesn't necessarily mean it's at the beginning. Hypothesis goes after if, conclusion goes after then. Make sense? Good, excellent. Number 2, you have to do this a few times on your assignment. Write this statement as a conditional statement. Conditional. If and then. Conditional statements contain the words if and then. So take this horribly written sentence, an acute angle measure less than 90, and rewrite that as an if-then statement. So I'll give you your first 3 words. If an angle. And then use the rest of that information to finish the sentence. You could say if an angle is an acute angle, then its measure is less than 90. That's one conditional statement. You could write the converse of this. You could say if an angle's measure is less than 90, then it's an acute angle. Both of those would work. They're if-then statements using that information. They're actually just converses of each other. I just flipped them around. Please make sure when you're writing these statements, you could hand it to your English teacher, and he or she would know what it says and give you full credit for the punctuation in words. They just may not know what it means. Do you know what I'm saying? Okay, sometimes you might have to add and delete words for it to actually make sense. 3. Find a counterexample to show that this conditional is false. It only takes one counterexample to make something false. And you have to remember, counterexamples need to keep the hypothesis true and then make the conclusion false. So the statement we're trying to find a counterexample for is if x squared is greater than or equal to 0, then x is greater than or equal to 0. You have to go back and think. Greater than or equal to 0. What does that mean? Anyone? Greater than or equal to 0. Marcel? Okay. Caitlin? Well, what does it mean if x is greater than or equal to 0, though? Okay, but what do you mean by bigger than 0? Just make a bigger 0? Good. Positive number. Good, Caitlin. Greater than 0 means you're looking at positive numbers. So this thing is saying if x squared is positive, or 0, then x must be positive or 0. We're trying to find a counterexample for that. So we have to keep this part true, that x squared is positive, but then we need to make this false. Well, if they're telling me x has to be positive, how can I falsify that? Make that false. Use a negative number, because that's going to make your conclusion false. -6. If I put that in over here, Ross, what's -6 squared? Positive 36. Good. Is 36 greater than 0? Yeah. But is -6 greater than 0? No. So this would be one counterexample. Any negative number would work, but you just need to give me one. So you could say -2, -18, -432. Wouldn't have mattered. Okay. Counterexample, keep the hypothesis true, the conclusion false. Last one on this side, write the converse of the following conditional. If x equals 9, then x plus 3 equals 12. Haley, what's a converse do? Yeah, but what's it do to the original one? Flips what around? Good. What's the hypothesis of this conditional? What about the conclusion? Good. So then you said the converse just flips those two around. So you should have x plus 3 equals 12, then x equals 9. Converse swaps those around. Questions on the first page? Okay. So check your number 5. I hope you got that one right. On one line under y minus 3 equals 5 and 2 under y equals 8. Hypothesis, conclusion. Number 6, to find a counterexample. Your hypothesis has to stay true. So I have to find a state with the word new in it. I listed the 4 of them. Counterexample, you have to find the one that does not border an ocean. Definitely not New Jersey, thanks to Jersey Shore. Oh. New York has Manhattan Island or whatever it's called, so that's all in the water. New Hampshire I haven't looked up yet, but I know New Mexico doesn't. New Hampshire, I don't know if the top northwest part borders anything or not. It's a river? Thanks. We were debating that earlier today. New Mexico, down by Arizona. Oh, it is? Okay. Good call. All right. Number 7, here we go. Write the converse of the conditional, then determine the truth value of each of them. Converse switches your if and your then around. So the converse would be if a equals 5, then a squared equals 25. This is the part you'll forget on your assignment. You're supposed to go back and determine the truth value for each of them. So for both of them. So if I look at the converse, if a equals 5, then does a squared have to equal 25? Okay, so then you can write true or just put t back there. That's a true statement. If a is 5, then a squared must be 25. The conditional. If a squared equals 25, then does a have to be 5? Pop, are you shaking your head no? Excellent. A could equal -5 and still make it a squared being 25. If you're going to say false, you have to have a reason why. You have to give me a counterexample then. Back up your reasoning, back up your answer. We're going to skip 8, go to 9. Here are your converses. That first one, if two lines are parallel, then they don't intersect. Converse for B, the absolute value of x equals 2, then x equals 2. It may not be word for word on the first one, just make sure your sentence is clear to read. We're supposed to go back and decide the truth value. I'll just start at the way top and work my way down. If two lines do not intersect, then must they be parallel? Okay, those of you saying no, you have to give me a reason why. Good. It's converse. If two lines are parallel, then they don't intersect. True, that's the definition of parallel. B, if x equals 2, then the absolute value of x must be 2. True. Converse, if the absolute value of x is 2, then x must be 2. False, give me your reason why. Good, x could be -2. Careful on those. Which one should be false and which one should be true? Some of you knew one of them had to be false. Just make sure you pick out the correct one. Very last one is 10b on your paper, 10b. Give me a counterexample. All numbers containing the digit 0 are divisible by 10. Like evenly divisible by 10. Sorry, good job.